I'm going to just provide a bit of an introduction and a bit of an overview. So on the next slide, you'll see that there's a reminder that each session will be recorded. That's us now. It just takes sometimes a minute for the slides to catch up. So each session will be recorded, and that's sort of twofold, the benefits of that. And that's to allow other participants who were unable to attend tonight's session to access the training in their own time. But it also allows you additional time to revisit and maybe engage with some of the highlight messages at a time that's more convenient for you. It's a good idea for you to familiarise yourself with some of the accessibility functions within Teams, and that allows you just to customise and change the settings to suit your own needs, and it does maximise the presentation and the overall experience for you. We do know that Teams and IT in general can be quite temperamental at times. So if you lose connection or for whatever reason you can't hear or maybe see the presentation, it is always better to leave and try and reconnect and join again. For whatever reason, that normally does provide the fix. You'll see that our email address is there on the bottom right of the screen as well. So again, if there is anything that technology lets us down, take a wee note of that address and maybe get in touch with us about that or any concerns. So we're going to start tonight with a bit of a connector. We thought it might be quite nice to just get us started. And this is the question that we would like you to think about if you've got any capacity to think left at the end of a busy day. We want you to think about if you were invisible for a day, what would you do? So I'm going to stop talking just for a minute or two, and it would be nice if you either just thought about it, but it would be even nicer if you could pop some of your thoughts or your comments into the chat pane. So if you had the luxury of being invisible, what might you do? And I'll stop and allow you to think and post some comments into the chat. Oh, thank you. Yes, me too. I would probably like to get on a plane somewhere, go somewhere nice, somewhere hot perhaps, because it's not sunny here, unlike Dundee. I noticed in one of the comments in the chat, somebody is saying they're from sunny Dundee. It's not so sunny here in Glasgow at the moment. So yeah, I might like to go unnoticed on a plane, visit somewhere nice, or stalk my favourite celebrity, which is a bit creepy. The other thing I would quite like to do now that I'm thinking about it is I watched that programme, it used to be on, I don't know if it's still on, and it was Michael McIntyre who used to take somebody's phone and send text from their phone. I think that would be quite good as well. Sitting on and driving lessons, yes. I love it. Sneak into the BBC? Yes. Oh, I love that one. Yes, I don't know if that would be a good thing or not, being in the House of Commons. It depends, I suppose. Reduce the energy prices, indeed. These are brilliant. Oh, thank you to everyone who's engaging with that. We quite like to start off in a bit of a fun way, not so much just numeracy and math related, but just to get people to think in a kind of fun way. So just keep these coming whilst I'm going through some of the overview and introductions, but we'll move on just now, Jacqueline. So if you've came to any of our sessions before, you'll know that we have a car park. And the idea of the car park is just really that it gives you the opportunity to post any comments, to ask any questions. And between Yvonne, Jacqueline and I, we try to check in on that as and when we can. You can post it in the chat pane, obviously, but if you want an anonymous question posted, then follow the link that's in the chat pane just now, and that will allow you to just, share anything with us that you think might be quite important, and we'll try and answer it when we can. Sometimes when we look at the car park, there's questions in there that are quite detailed, and that might be one that takes a wee bit more time, and as our sessions are normally quite full, so we don't often get the chance to really unpick some of the themes that come through. But what we might do is pick up on some of the questions or comments in one of our drop-in sessions. So I'm going to just talk to you in the next slide about the drop-in sessions as a bit of a reminder, but also to talk about what the purpose and the aims of the drop-in sessions are. So you'll see in the slide just now that the next drop-in session is the 2nd of February. The aim of the drop-in sessions really are, well, they're less structured, they're less focused. We don't come with a presentation. We encourage people to come and share their own experiences. We might want to look at some more detailed and specific questions based on what you bring, so based on your own context and the experiences that you have with your learners or with your peers. We might want to talk about something numeracy and math related that we've not covered in the course. We might want you to share some of the learning that you've taken from the sessions or from any of our professional learning reading materials and how that's been received and what the impact of that has been. In the next drop-in session, we might be asking you to think about what the content of the live session that's still to come, so the one in May, we might be asking for your feedback to shape what that session might be. So there was, as I said earlier, there was a question posed during the last session, very detailed, one that we wouldn't do any justice or answer effectively during the live sessions because we've got so much content to cover, but that would be a great use of the time allocated in the drop-in sessions. So again, if there's something in particular that you've got that's just a bit of an itch, please come to the drop-in sessions with that question in mind. Or it might not even be a question, it might be a success, or it might be something that you just want a wee bit more clarity on. So keep that date and that time in your calendar and please join us if you can. We would love to see you there. So we're going to get warmed up a wee bit more now, just more thinking about numeracy and maths. So what we want you to do just now is think about the images that you can see on the screen just now and put into the chat pane, how are the two images the same but different? And again, I'm going to pause just now just to give you a wee bit of thinking time. It's always difficult being the first person to pose something in the chat pane, and it's also difficult for me to give that thinking time, so I am going to stop talking. Thank you. I can see some thoughts coming through now. Great. Yep. Yep. So the value are the same, it's just the way they're presented. Absolutely. Great. Thank you. Yep, so these types of starters are actually very good at just getting learners to think. And if we're not doing that, then, we need to be questioning why. So we really want learners to be thinking, but thinking deeply. And what we really want to do, if I was doing this live with you, if it was face-to-face, sorry, what I would do is I would treat it as I would in a classroom environment. So I would pose the question as I have done tonight, and then I would allow you to think about it for a minute or two. You read the room, when is enough time. But if I was doing it in a classroom environment, I would then get my learners to turn and talk and share, get the ideas out of their head and get them to share them. They might want to just talk about that. Alternatively, they might do that and record them on like a mini whiteboard or something. But then you want to bring the whole class together to share. You want them to think about how are the two images the same but different. Again, you might want to think about, can I record that on a T-chart with maybe one side for the same, one side for different? Could use a Venn diagram as well. The important part is that we're doing that as a whole class. We're gathering all of those ideas and we're recording them or summarising them somehow. And then that brings us on to the next bit where we're doing that summarising. Let's just clarify that we now know both of the images are the same, but they are different. And again, it's about going over the ideas that the learners have shared with you and calling attention to what's the important mathematics that you want to draw out from their sharing and from the discussion that you've either listened to or observed. And the next step would be the application. So could our learners then create another same but different image that shows the same mathematical idea? And allowing the learners to then work in partners or in small groups or individually if they want to come up with a related same but different image. And again, having them share their images. And again, it's going through that process of the students moving towards that generalisation of the larger mathematical concept. And it is important to notice the word but. So what we're doing there is instead of them making a choice, am I going to prove that these are the same or am I going to prove that they're different? The learners are considering how two items can be both. And that's a critically important distinction. They're not the same or different, they're the same but different. And again, when using these types of routines, what we're seeing is that learners are forced then to look at the features, the characteristics, the defining qualities of what we're comparing. And it really helps develop that mathematical thinking and develop the problem-solving skills that we're going to talk to you about tonight. So Hazel Simpson, sorry to call you out, but I know you had put in the chat the link that was on that last slide. If you follow that link and you'll get a copy, you'll be able to do that. There's lots more ideas there that you can then use in your context, or anybody can, but I just wanted to call that out because you had asked specifically about things that you could do maybe in an online environment. So what you'll see in the slide just now are the skills that are embedded within the numeracy and maths benchmarks. In our experience, these are quite often overlooked, and the focus is on the E's and O's in the benchmarks, which are important. But there does remain a bit of a misunderstanding across the system about what the skills are. If we ask that question, or if you had to ask that question of your peers, you would maybe get people saying, oh, is it about addition? Is it about subtraction? And when we think about the skills, we know that questioning is at the heart of developing these crucial lifelong skills. We know that we're in the job because we want our young people to be sophisticated thinkers. We want them to spot patterns. We want them to solve problems. So therefore our job is to empower our young people as mathematicians. And the development of the skills that you see on the slide just now can really help that. They can be developed through careful planning of our learning activities, the pre-planning of questions, and the range of assessments, maybe formative assessment strategies that we're using. But what they should do is encourage learners to think about the concepts, but going beyond that recall of knowledge, really encouraging them to explain their thinking, interpret the questions, share and learn from each other. And we hope that that would lead to that deepening of understanding. And as you can see on the slide, what we're hoping is that as learners progress through the Curriculum for Excellence levels, they start to demonstrate increasing sophistication and independence in their ability to demonstrate their understanding, to make links across learning, to transfer and apply the skills in a range of increasingly more challenging contexts. The next slide, we really like the illustration. So we like this, it's about mathematical behaviours. You might have heard the name Mike Askew before. He's quite a predominant professor of mathematics. And really what it proves is it's that interesting presentation on reasoning, which starts with a quote. Math is not a spectator sport. We know that. We want our learners to really engage with maths. We want them to think. We want to encourage them to think deeply and help them get better at mathematical thinking. We know it's a challenge, but in that article that you'll see there, Mike Askew discusses how it's important that learners become fluent in the fundamentals of mathematics through varied and frequent practice with increasingly complex problems over time, so that our learners develop that conceptual understanding and the ability to recall and apply knowledge rapidly, but more importantly, accurately. We know that learners need to reason mathematically by following a line of inquiry, thinking about conjecturing relationships, making generalisations, developing an argument, justifying their choice, proving it using mathematical language. And finally, we want learners to be able to solve problems by applying their mathematics to a variety of routines and non-routine problems with increasing sophistication. That might include breaking down problems into a series of more manageable steps. We also want them to persevere, seek solutions, make mistakes. And the suggestions in the learning activities that we're going to share with you in the next few slides will hopefully help learners develop these types of reasoning skills. So again, I'm going to pause for just a minute or two to let you think about this question. Now you can reflect on it, but it would be even better again if you could just put into the chat pane, how often do you plan for problem solving? And I'll hold off for a minute just to see what comes through the chat pane. Not enough. Thank you for sharing that. Thank you. And I have to say, back in my own experience, I would probably have agreed. And it's that what's a priority? Yep. Hazel, not having enough time. You've got, yep, the basics. Yep. Great. Very honest reflections here, and that's exactly the reality. Yep. Trying most lessons, Francis. Yep. So I suppose what we're trying to get to here, and please keep these coming, is that problem solving should, in an ideal world, be central to everything that we do. Our learners should be problem solving all the time, even if it's not framed under a problem solving lesson per se. And we know that there are no specific curriculum organisers, experiences and outcomes related to problem solving, but we still would advocate that problem solving should be embedded across all areas of maths and shouldn't really be seen as a separate entity. As I've mentioned, it should be embedded across the curriculum, but the focus of today is in ways that we can do that through a numeracy and maths experience. Our ability to successfully problem solve requires us to have a deep understanding of content and fluency of facts and mathematical procedures, and perhaps focusing on the skills that I mentioned earlier on, and thinking about one skill or two skills that we want our learners to develop, and then planning and offering opportunities for you to model that and revisit that and really get that depth of understanding can help learners realise that there's lots of different ways to solve a problem, and the focus should move away from the answer but on the process taken to reach that answer. Being a mathematical problem solver really is the point of doing numeracy and mathematics. It will enable children to understand the world they live in, also develop the ability to reason mathematically and have that appreciation of the beauty and power of mathematics, which again should hopefully lead to a sense of enjoyment and curiosity about the subject. And we'll talk a wee bit about this as we go through the presentation. So we want our young people to engage with mathematics. We want them to build their comprehension of the subject across the curriculum. Our purpose, therefore, is to offer a better way to build mathematical understanding in and beyond our classrooms. The skills that you're going to see pop up on the screen really highlight these lifelong skills we rely on, and it's our job as practitioners to nurture and develop these as we engage with our learners. So creative thinking, critical thinking, these skills are essential components of problem solving. Creative thinking is about looking at a problem in lots of different ways. It might involve seeing a different way to do something or generating new ideas, using materials, concrete materials, in unique ways. Basic to being a creative thinker is a willingness to take risks, to experiment, to explore, to make mistakes. These are all crucial. Critical thinking is also about the ability to mentally break down a problem or an idea into smaller parts. We want them to analyse them. We want them to sort, classify, compare what's the same, what's different. These are all part of this important skill. And there was a quote that we found that we could share with you, and it's really important maybe to consider this. The quote talks about mathematics being really important because it's a gatekeeping role, so it allows people to access educational and economic opportunities beyond school. But actually, it's also because the process involved in problem solving and the acquisition of the skills and the strategies that we're talking about today will equip them for beyond life and beyond school. So it's really important that we keep that in mind, and it really is about that, not the memorisation per se, but it's about students being able to develop understanding and explain the process. How did they arrive at the solutions, rather than remembering and applying a set of quite fixed procedures. Quite often what we find is that learners maybe have developed their procedural fluency, but often they lack that deep conceptual understanding, which is absolutely necessary to solve new problems or make connections across mathematical ideas. We want and we need our learners to think. And our role is really important in that. So on the next slide, we talk a wee bit here about the importance of our expectations of our learners, which is absolutely essential. We need to make sure that our learners are handling complex problems, and they won't do that unless they're being exposed to them. The problems need to be difficult enough to provide that wee bit of challenge, but not so difficult that students are panicking and there's anxiety and they feel they can't succeed. We're thinking here about that kind of zone of proximal development. We want them to get to the answer through perseverance. So it's about thinking about where our learners are at and what that looks like in our context. We need learners to have opportunities to explain their ideas, but also to respond to the ideas of others. We need to challenge their thinking. For those learners, and we might be thinking of a few at the moment, who just want to focus on the correct answer, those learners are the ones that will need a lot of support, will need a lot of encouragement to take those risks, because that tolerance of difficulty is absolutely essential in a problem-solving disposition. That being stuck is an inevitable stage in resolving just about any problem, whether it's numeracy and maths or life problems. But the getting unstuck takes time, and it involves learners trying different ways, a variety of approaches. It needs to be hands-on. They need to investigate, they need to explore, they need to learn this experientially. And we're going to look towards the end of my input at some question stems that might help develop that level of engagement and thinking and understanding that we are promoting. The next slide is a video clip. I don't know, Jacqueline, do you think we've got time to watch the video clip? I think it's only 2 minutes 47.
Yeah, it's just crashed, sorry. It's just disappeared.
Well, I could put a wee link to it in the chat if that would be easier.
No, it's fine. I can. I just need to reopen it again. It just disappeared. Didn't like that.
I told you that it's temperamental.
I know.
Well, whilst Jacqueline's getting that ready for us, we are going to share the clip. And what I would like you to do is, as you're listening to the clip, think about your own context. Think about whether we provide enough opportunities for our children to be stuck. And if we do, are our learners confident in that space? What do they do when they're stuck? Who do they go to? What is their go-to strategies and approaches? And how can we as practitioners promote that resilience and perseverance, especially in mathematics? Again, you might want to think about how do we help shift that mindset that being stuck is actually a productive space to be in, and how do we make sure that our learners can identify with that? And as teachers, practitioners, do we model that being stuck? And what do we do about it? Because a lot of the time, as we know, our learners are looking at us as role models. And if we can model effectively that being stuck as part of the learning process, our learners are much more likely to engage with it. So be thinking, I know that's quite a lot, but be thinking about your own context and your own learners as you listen to the video clip.
It's not working. I think it's the video clip is corrupt for some reason, and it's not, every time I go to that slide, it's not working. So I wonder if we even just put the link in the chat, or I can send, I'll send the link out actually in the email I send out tomorrow. I think that's probably better. I'm just going to try and reopen this and avoid that slide now.
I posted it in the chat just for people to take away with them, just because it is quite a good clip and it does make you think. And if we're promoting that our learners should be thinking, I think that's quite a good one. And maybe think about those questions that I posed as you're listening to it, and share that with peers. You know, do we do enough of this? How could we do a bit more in terms of promoting that resilience and perseverance? So we'll move on, and people can revisit that after the presentation or in their own time. So thank you. So there's a few points here that we want to reflect on. All too often we see problem solving being timetabled as a separate element, and I've spoken a bit about that a wee bit earlier on, perhaps being the lesson that we plan for a Friday. What we would advocate is that learners should be problem solving all the time, every day. What we would say is be careful if you've got displays in your classroom that match certain words to certain types of operations, because in problem solving, learners need to understand the context of the problem. Then don't just maybe look for the keywords, and I'll show you an example. There's one coming up on the slide that maybe would send our learners down the wrong route in terms of what calculation they might do. So if you look at the one that's on the screen just now, if they're pulling out keywords, think about what the learners might do if they're presented with that and they're only picking out the main words but not looking at the problem in its full context. We know that some words in numeracy and maths can be used for more than one type of operation. So when we're thinking about the difference between can be a subtraction, but it can also be solved by counting on. So what we're not saying is go back to your classrooms and pull these, wall displays or these, posters off your wall, but just be careful, when you're doing that the learners know that there are different ways and different strategies that they might want to use to solve some problems. We know that word problems can be complicated in part because of the descriptive language, and a lot of our learners maybe don't understand what exactly they're being asked. And I know in my context, learners would say to me, just tell me what it is I have to do and I'll do it, because it's too wordy and I'm losing myself in the question. And that's compounded if the problem involves some abstract concepts. We know that sometimes our students might lack the fundamentals of maths and maybe can't formulate a plan for solving or separating out the problem into manageable steps. I read a paper quite recently, and it spoke about problem solving and the effectiveness of using knowledge in new situations, and that being influenced by the appearance and the context of the problem. The article went on to suggest the development of problem solving skills being related quite closely to the level of reading comprehension, and we know that. For me, what I started to think about and what I wanted to consider was, how do I present my problems to my learners? Do they all need to be presented in written form? Can we read them aloud to some learners? Would that help them access the learning a bit easier? Could we present the problem in more of a multisensory fashion? And again, yes, EL children and children who have maybe math differences, these are the learners that I'm thinking about here. So could we think about different ways to present our problems? We know some of the strategies that are used within our schools when they're drawing pictures and they're acting it out. These are really crucial. It's important that learners are given time and space and structure to use that range of strategies. And again, think wider than numeracy and maths. Some of the skills that I've spoken about in this part of the presentation are transferable across the curriculum and beyond. And that's what we want for our learners. We want them to see the links and be able to take that skill and apply it in a new and a different context. We talk all the time in our presentations and in some of the materials that we produce about the words explore and investigate. And we use the phrase I wonder all the time. Some of the activities that you're going to see pop up here are examples of ways to promote that mathematical curiosity, which is so important and so needed in our learners. And I'll post a link, or a couple of links actually, to some articles that we came across, and they're produced by NRICH. Some of you might already be familiar with NRICH. Great website if you're not familiar with it. But one of the articles shares that notion of the progression in developing curious learners and deep thinkers. And they break it down into steps. So step one is the noticing. What are learners describing? Are they describing what they see? Can you use prompts and things like what's the same and what's different? And that's why we put that in as a starter. And moving on from that noticing, moving into the next phase, which is wondering. We're starting to get the learners to ask questions, I wonder if, or what might so-and-so think, or what might I do differently? Again, so this is all important. All this steps are really important. Moving into the investigating stage, where we want the learners to then demonstrate their problem-solving skills. They might draw on their resilience and perseverance if they get a wee bit stuck. What do they do when they make the mistake? Can they easily try a different approach? Step 4 might be reflecting and creating. Curious learners are both problem solvers and problem posers, so they might think about devising a new problem. They might tinker with another challenge. They might reflect on their learning and suggest hints for other people to help them investigate similar problems. So there's a couple of NRICH articles, and as I said, I'll put them into the chat. Again, thinking back to that earlier thing from Hazel, there's a couple of links here that might help you in terms of, one of them's a full page of problems, which really exploits learners' natural curiosity and provokes them to ask good mathematical questions. Oh, thank you, Jacqueline, you've beat me to it, putting those in. So these are ones that we would promote you to look at and think about pulling some of the learning from that for your own learners. The next slide is the last slide for me, and this is just a wee example, or a couple of examples of the types of questions that you might want to take away with you that will really support that mathematical thinking and that deeper engagement with learning. Hopefully by using some of these prompts, it will help guide and support and stimulate your learners. These types of approaches provide opportunities to expose and discuss common misconceptions, but also encourage that reasoning that I spoke about earlier on, rather than just what's the answer, take me straight to the answer. It is focused on the process. They also allow for creating connections between areas of learning. Practitioners should model effective questioning. We should value all responses and contributions and challenge correct and incorrect responses. So when we're thinking here, it's about that metacognition. We want to support progress and personal achievement. We want to support learners in developing their own ways of thinking and knowing when and how to use particular strategies for problem solving. So for example, what is the most effective strategy in this case and why do you think so? So it's all about that, just continuing to think a little bit deeper. So I'm going to pass to Yvonne just now, and Yvonne's going to share some activities with you that will hopefully back up a lot of what I've said so far.
You there, Yvonne? I can still see Yvonne in the...
I was about to say I can see Yvonne in the call, but I don't know if she's maybe having some IT issues.
Until we can hear her voice, then what we can do is we can just carry on. So what we'd like you to do is, if you could go to this, you can use your phone or tablet or whatever to scan the QR code, or you can just go to menti.com and type in the code, or maybe you could get the link if that's all right and stick it into the chat. And then what we want you to do is just click on the ones that you've used before, what strategies you're aware of. Maybe you've used them, maybe you've not, maybe you're just aware of them, that's fine. And you can pick more than one, so if you've used more than one, that's fine. If there's some you just think, I've got no idea what that is, that's fine as well. And we'll just give you a wee moment or two to do that, and then we'll show you what the kind of results are, what the trends are within the group. And if you've got any issues with that, just note in the chat. And that's Maria posted the link in, so thank you for that. So Yvonne has just messaged me, our Teams has crashed. We're having little gremlins tonight. What's going on?
Here,
oh, you're back. Oh, good, good. We held the fort.
Have you given people the Menti code?
Yep. So they're just filling it in. We're just giving them a wee moment to fill it in, and then I'll put it on the screen so everybody can see what it is.
I take full responsibility for that, for saying IT can be temperamental. I think I have jinxed it. Sorry, guys.
At least everyone got back. I always think that would be a great thing if you really just didn't like a meeting. Oh, I get cut off, sorry. Okay, so people are still adding just now, so I don't want to, I'll put it into the screen just now so you can get an idea. So the popular ones are which one doesn't belong, always, sometimes, never, open-ended questions, and Venn diagrams. The other four aren't maybe just as well known, so that's quite nice. So what we kind of hope from this is that you'll get to know some new strategies today, because you can't use them all at once. So hopefully you'll pick something from this that you can go away with. But I'm going to mute now and hand back to you, Yvonne.
Thank you. So the kind of first activity that we're going to look at is called Which One Doesn't Belong. If you have been along to any other presentations before, or you have watched some of our recordings, you might notice that we do use this one quite a lot. We often use it as a starter. And this is basically where you present 4 different options and you ask the children or the learners or the adults or whoever you're working with to discuss which one of these is the odd one out or which one doesn't belong. So I'm going to give you a moment to type into the chat and tell me which one of these cards doesn't belong. And if you can justify your answer as to why it is the odd one out, that would be great. Okay, we've got people saying that it's the 7 because all of the rest are diamonds. Somebody said it's the ace because it's out of sequence. Ace because it's the only letter, the rest are all numerals. Somebody saying number 8 because it's even. And so essentially what you'll see is that actually each one of these cards could be the odd one out. So really we're not looking for a right answer here. What we're looking for is for learners to be able to suggest a reason for why it is the odd one out. This type of activity is really good to use as a starter, or you might use it as a recap of previous tasks, or you might use it to lead into something new. And you'll see with some of the other examples that we've included on the slide here, you don't always have to use things that are related specifically to maths. You might want to use things that you've been covering if you've been doing things like fractions and decimal fractions. But you can see there, there's biscuits that you can ask them. It's that kind of mathematical reasoning and mathematical justification that you're really trying to hone in on. You can show the whole class the same 4 things. And the good thing about this type of activity is that it's kind of naturally differentiated because children answer it at the level that they are working at. So, with the likes of the one that's there with the decimals and the percentages, some children might just say, 50 because it ends in a 0, whereas others might begin to look at multiples and how it's linked and how, how fractions and decimals are linked. So depending on where they are within their stage of mathematical learning, depends on the kind of answer that they will give you. And so a really good one that we can use in lots of different ways across our numeracy and maths lessons. Now, the next example is always, sometimes, and never. And this starts by having 3 different cards or having it written up on your board, always, sometimes, and never. And then you pose different types of questions and you're asking the children to work out, is this always true? Is it sometimes true, or is it never true? So you'll see the first one that came in there is that the sum of 3 numbers is odd. So if you put into the chat, is that always true, sometimes true, or never true, that the sum of 3 numbers is always odd? Okay, the people that are putting sometimes, can you elaborate on when it is true and when it isn't true? Or can you give me an example of when it is true? Okay, so Hazel, great, you said sometimes, so 2 plus 2 plus 2 is even. Lorna saying that it's true for even numbers. If you add 3 even numbers. Okay, Joanne saying it depends. It's not true if you're using 3 numbers are not even. 3 odd numbers will always add to odd. And so again, you'll see that children will give you very different answers depending on their thinking, and the way that you began to work on this one will probably have been very different. So some of you will have started in more of a kind of logical order, so you might have done things like 1 plus 1 plus 1 and 1 plus 1 plus 2 and 1 plus 1 plus 3. Some of you might have looked at much larger numbers. Some of you might have gone with different types of numerals, tried some negative ones in there. And so just like the previous kind of activity, we could ask the same question to a group of learners at a range of stages, and they would all kind of give us the same answer in terms of always, sometimes, never, but the mathematical justification, that kind of how do they know, will be very different, from very basic to very wordy explanations. Some might be able to begin to present to you their findings. They've started with a kind of table writing out their answers, and kind of some might be using concrete materials to explore it. And again, it's really good that you can use these in different ways. So for example, you might then ask them, well, can you make the statement so that it's always true or that it's never true? So again, a good one that can be used in lots of different ways. Now, you often hear people talking about open-ended and open-rooted questions. These are really helpful for helping children to develop their problem-solving skills, but it is important to understand the difference between an open-ended and an open-rooted question. So an open-ended question has lots of opportunities for different strategies to be used, and there's lots of different solutions. Whereas an open-rooted question, lots of different strategies can be used, but there's only one possible solution. We have a mini guide on this, so if this is something that's relatively new to you, you'll be able to get the link from the slides and you can have a read through that. Again, lots of different ways that it can be used for differentiation. and the ways that they can be used for assessment. So you can see the ones that we've got on the screen here. We've got some at early, some at first and some at second. They've just been lifted directly from that mini guide. And you can see how learners would be using lots of different solutions, and the way that they work it out will be different. The answers that they give will be different depending on their kind of age and stage of mathematical development. Now, on the next slide, I'm just going to pause for a minute. Now, I don't want you to tell me the answer, but I'd like you to tell me, how would you work this out, 37 plus 25? Okay, so somebody's saying they would do 35 plus 25 and then they would add on 2. Somebody's saying that they would add on the 10s first, so they'd do the 30 and the 20 and then they'd add the 7 and the 5. Somebody's saying that they would split the number up into 30 and 7 and 20 and 5. So you can see in the chat lots and lots of different ways that people would work this out. And if you have watched the addition and subtraction videos, you'll hopefully remember that we have included this slide. This is an example of how a question can be used in an open-routed way. So there is only one possible answer. The answer is 62. But by asking children to discuss how did they get that answer, then you can begin to discuss some of the different strategies that we've used. And as we've mentioned before, it's really important in helping learners to understand that there can be more than one way of working things out, and open-routed questions are a really good way to help that. And I noticed that some people were saying that they're using things like number talks. Again, a really good opportunity just to encourage that sharing of strategies and that mathematical discussion. Often, I know as a teacher, I spent a lot of time looking for problem-solving questions and problem-solving activities. And actually, if we just get a little bit better at changing the wording of questions that already exist, then you've actually got a lot of ready-made questions for problem-solving activities, and all you've had to do is kind of tweak a few words. So you can see here in this first example, this is something that you would find in lots of different worksheets and textbooks and things like that. Calculate the perimeter of the shape. But you can see that if we change the wording very slightly, so instead of saying find the perimeter of this shape, if I was to say how many rectangles can you draw which have a perimeter of 24 centimetres, that makes the question much more open. It allows the children to interpret the question carefully, and then they can decide on how they would go about solving this. And on the next slide, this is an extract from a maths blog which talks about some of the ways that you can open up closed questions. So you can see that some of the examples are there. So things like asking for similarities and differences, you know, how are they the same, how are they different, asking for explanations, so we know that 4 is a factor of 2 different numbers, what else might be true about both numbers. And again, a really good article, and this is a good slide just to kind of keep handy when you are beginning to think about designing different questions for problem solving activities, to have close to hand. And on the next slide, we're just going to give you a couple of minutes just to have a wee go at this. So you will see here are 3 closed questions. Type into the chat, you can choose the one that's kind of most relevant for you. Is there a way that you could make that a more open-ended question? Okay, for that middle one there, how many different ways can you make 10? What numbers could you add together to make 10? Okay, so I'm just saying there I've got 45 pence in my purse. What coins could I have? What is the least number of coins that I have? You could explore, show me the different ways to make 45 pence. What coins do you need to make 45 pence? Okay, somebody's saying that for the top one, instead of just that one question, you could say, how many different ways could you make and then give the answer. So again, you can see that actually, that didn't take huge amounts of planning and trawling through different sites and worksheets and workbooks and things like that. We just take some commonly used things and make them a bit more open. Another site that's really good, that's got lots of different examples of open questions that you can use, is called Open Middle, and we've included some of the questions that you can find on here. Hopefully you can see how one question can be displayed, and actually it can be tackled by children who are working at lots of different levels. You might also decide to differentiate these even further. So thinking about this example, it would be too challenging for some of the children that I'd worked with using the digits 1 to 9, whereas if I was to say that you could use the digits 0 to 9, then they would be able to complete that. So again, a very simple differentiation technique in there that then opens it up to maybe some of my children who may be needing a bit more support there. These are American, and you can see that here again are some of the examples. So you do sometimes have to change the word, and I think we've got one there where we've had to change the favourite colour, the spelling of colour there, but it doesn't just cover things from the number and number processes. There's lots of different things that you can use. And I'm now going to hand you over to Jacqueline, who's going to share some of the other types of problem-solving activities that you might use with your learners.
Thank you. What we're going to do is we're going to look at an approach, and then we're going to have a very quick screen break, because I'm aware that you've been sitting listening to us for quite a while. We have tried to make it as interactive as possible, but it can be challenging just sitting at a computer. So we'll stop after this next strategy and have a wee screen break, just so that you know that it's coming. Sometimes that just gets you through a little bit. So the approach we're going to look at just now is called numberless word problems. I could see from the poll earlier, this is one that's not as well known. Some people do know it, and that's great, but not everybody, a lot of people weren't actually aware of this. And I've got to say, it's one of the ones that I kind of thought, wow, why have I never thought to do this before? Because I think it could be quite powerful as well. So you might find that if you were to present a problem to children, that they might go straight to the numbers without really considering what the question is asking them. And I know that I find that all the time with the children. They just didn't read it properly. You were saying, good, just read it properly. But see if we're actually honest, even as adults. How often do we do it? I know that I'm always in a rush and I always want to do things, so I'll go and I'll grab the minimal amount of information that I need, or I think I need, without actually paying proper attention to it. So the numberless word problems can slow all of this down, and it can just stop the learners from doing that number grabbing and just give this a bit more paying attention to the actual language. So let's have a look at this first bubble. What maths do you see in that? So take a wee moment, type it in the chat, have a think about it. What maths do you see in this? Fewer, thank you. Fewer. Some. Okay, good. So probably, in all honesty, if you gave this to learners, some or a lot of the learners would probably say there's no maths, there's no numbers. But what I would do in that case is I would just say, well, look again and wait, and eventually they would probably come to the same realisation as that you have here. You've just got to it quicker. You know, the words fewer, some, there's comparison, that sort of thing. So it's just, again, it's stopping, slowing it down, and getting them to pay attention to it. But it's not actually asking them to do anything. So then you would reveal the next part, and we do have a number now, but we still have to stop and think about it. So we know now that 135 children were in the lunch hall. What else do we know? Have a wee moment to think about that. You don't need to stick it in the chat, but just take a wee second or two to consider that. So essentially, we know that there must be less than 135 adults. And then finally, you would reveal the last part, and by this point, all your children have had time to really stop and think about this and consider what it's actually saying. And it does provide that opportunity to pick apart the language that is used within any of the problems. It will be different language and different problems that you're looking at. But you'll also notice that there's not any questions that are being asked at this point. And you could get learners to create their own possible questions given the facts that they've been presented with. You know, they might make questions up such as what was the total number of people in the hall, or how many more children than adults are there. These are the kind of things that they can do. You could then present a question to them. That's up to you. Again, it depends on your learners and your context, but that's just sort of one way you can do it. This kind of version that I've given you today is a very short version of how this approach works. But if you read this click on this link at the bottom when you're looking through the presentation again. I do recommend that you read this, Teaching to the Beat of a Different Drummer, written by Regina Payne, and she talks about introducing this to her class and how it worked, and it's just really easy to follow and will hopefully help you if you want to do this as well. There's also lots on this website, on this website here, the BStockers website, that tells you how to create these, lots of examples that you can lift and use as well, try it out. But what I would say is it's probably not something you would want to use for every word problem, you don't have the time, but it is a good way to prompt that rich discussion, and it can help to provide that scaffolding to support learners in paying attention to that information and the language in just a deeper way and become less likely to number grab, as I said earlier on. But what I would say with this as well is that with it being quite a new approach, it does take you and the learners a wee bit of time to get used to it. So if it doesn't work the first time, don't give up, try again, because eventually, you know, you would hopefully get there with it. And I think it is with any of these approaches that we're talking about tonight. Some of them are quite different to what probably you and your learners are used to. So just give it that time, be kind to yourself, and, you know, just start with something nice and simple and then try again if it doesn't work, because I think that's important. If you do choose to use the numberless word problems approach, then these are some of the questions that can be beneficial to use. There are quite a lot of questions here. Obviously, I wouldn't use them all at once because you don't want to overload learners with too many questions, but it's just a kind of bank of questions that you might be able to use if you use this approach. And as I said in the last slide, you can also challenge learners to create the questions themselves as well, using the information that they've been provided with. I'm not going to go through this example, it's just to show you another way that it can be used, and also the bullets on the left-hand side here just demonstrate how this approach can help to develop that mathematical thinking that Maria and Yvonne have been talking about quite a lot. So I'm just going to move on because I'm conscious of time, and I'm also conscious that probably everybody's ready for a little bit of a break just now. We'll take a screen break. That's 53 minutes past. We'll come back at 58 minutes past. I know that's very specific, but it means if we get finished earlier, we get started quicker, you can finish earlier as well, hopefully. Take a break, walk away from the screen, feel free to stay if you want, and comment on this graph. You don't have to, but what I want you to do is just have a look at this, and anything that you notice about it or anything that you wonder, you can stick it in the chat, but if not, you can go away and have a wee break as well. So we'll see you back here at 58 minutes past 4. Review graphs, and sometimes they're also known as numberless graphs or notice and wonder graphs, but essentially what these are graphs which are gradually introduced with a little bit more information added at each stage. And again, it's just slowing down the approach, a bit like the numberless word problems, and giving learners time to think and to wonder and to talk about things as well. And as more and more of the graph is revealed, what will happen is that learners will probably refine their initial interpretations, and sometimes it can be in quite surprising ways as well. It can be quite interesting having these discussions with your learners. So if we look at the chat, we can see that some people have noticed different things and are starting to wonder what the graph might be about, and maybe in your heads maybe started to think about, oh, what might this be about as well? And this is just exactly how I would do it with the learners. I would show them, I would give them time, and then I would add in the different bits as well. And I think probably one of the hardest part of this approach is that wait time. It's so important, and I think probably it can be effective just to give children time to think about it on their own, first of all, just to process their own ideas, then maybe talk about it with a shoulder partner or in a smaller group, and then have that wider discussion as well. But how you do that is down to you and your class and what works for you, of course, as well. So once you've had that initial discussion, you would then reveal a wee bit more detail. So what is this new information? Have a wee look at that and think about, what do we know now? I'm not going to ask you to put anything in the chat at the moment just for time. But again, I would just ask the learners, what do you notice now? Is there anything new that you're wondering? Has it changed your thinking? Have a wee think about this and take that time. And then you would introduce a little bit more information. So again, what is this new information? What do we have now? What do you notice? What do you wonder? What might this graph be trying to tell us? What might be in the x-axis? Now, what I would say is I've just thrown quite a lot of questions at you at once there, which I would absolutely not do with the learners and just trying to squeeze it all into the short time we've got. I just wanted you to see examples of the kind of questions you could ask, but it is best just to ask one question at a time and take that time to work through that as well. But you don't always have to ask the same questions. You can vary it up a wee bit again, depending on your own learners as well. And finally, the last part of the graph is revealed, and we can see that the graph here is representing the number of teeth that adult animals have. Now, if you thought that before you started this, when you saw the initial graph, well done. I don't think it would be likely that most people would. But it is important to think about how our thinking changed as we went through the process. What parts of the information made us change what we were thinking? And it can be quite a good opportunity to model this to our learners as well, so that, you know, the teacher doesn't always know the answer straight away. It depends on the information that we've got as well. And it is absolutely fine to change your mind as you go through the process as well. So again, the benefits of this, similar to the numberless word problems, is that it just slows the whole process down and makes learners pay attention to the different bits of the graph, rather than rushing to answer a list of, you know, preset questions that we've given them. Another good thing about it is that it can reduce that cognitive overload, with information being revealed a little bit at a time rather than all at once. And I think we've probably all seen pages in textbooks where there's a graph and then there's loads of questions and there's just loads, and even as an adult sometimes you're like, oh, where do I start? What do I do? So this is one way of kind of reducing that and helping them not become maybe so overwhelmed with it as well. And sometimes what we can find as well is if you just present them with lots of questions, some learners will just work robotically through it, but they won't actually take the time to really think about or analyse the information in any of the depth as well. You can see in the right-hand side that the slide shows some of the mathematical thinking skills that this approach can develop, and it can highlight how this can be a beneficial approach in relation to problem solving and, you know, not just data and analysis, which you would initially go to as well. And I think what we're trying to show you today is that problem solving should be embedded across all the different things that we're doing, rather than just that one-off block that Maria was talking about earlier on. And, you know, that's not to say we weren't guilty of it. The person who used to cover my non-class contact time would come in and do problem solving. So if I could go back, I would definitely change things as well. And as I said, you'll be given the slides as well. So if you're wanting to go back and relook at any of this, then you've got time to do that later on. This link here takes you to slowrevealgraphs.com, and there are lots of examples on this site, but they're very American, and actually I found it quite difficult to find ones that were suitable for our context over here. But I did find this one on food waste that could probably be used at second level, but I think it is still worth going in and having a look at the graphs on the site, because it might give you a wee bit of inspiration just to see what you could do with your learners as well. So another variation on this approach is the goal-free approach. So instead of providing learners with a stimulus and lots of questions that go along with it, and with the goal-free approach, you're just providing that stimulus. So in this case, we're showing you another graph, but it could be a shape or a 3D object or a pattern or a collection of money or anything that you think is appropriate. Again, it comes down to you and your learners and what their past experiences are as well. So once again, you would just give them this stimulus, in this case the graph, and you would say, you know, what do you notice? So let's do it. What do you notice? Stick it in the chat. And some of you might wonder something, you can stick that in the chat too. I think we've worn the group down, Maria and Yvonne. There's a lot of information here. There are a lot of good books, thanks Francis. I'm not going to spend too much time on this because I do also think that yeah, I appreciate that it's at the end of a long day as well. So thanks, thanks for the suggestions, everyone. So here you can see a link to the Sweller paper, and this paper that we link to, it talks about solving traditional problems that have a specific goal, and that can be cognitively demanding, particularly when the problem is in a new or unfamiliar context, which is what we're always trying to get to with the learners as well. But that's because the solution can only be found by completing all of the steps that lead up to it. And because of that cognitive overload, it can result in in a failure to solve the problem as well. And even if the problem is solved, it doesn't always lead to new learning as well. So when you've got a context presented with no specific goal, so you can see this here, it's not asking any questions at the moment apart from what do you notice, actually the solutions to lots of different problems can be found, and it can be explored at different levels that are appropriate to each learner as well. And often through the different discussion and dialogue that you have with learners, lots of the traditional questions that we would set learners actually end up being answered, but in just a much more natural way, and they don't feel that they're being driven. They feel that they're driving the process a wee bit, they've got more control over it. What we like about this is it's a really good approach for differentiation. You probably picked that up as I'm talking about it, as you can use it with all pupils, and they'll notice different things just depending where their own learning already is. It can also be good to use for assessment, as it can provide you with a really nice, clear picture of what the next steps are for each of the learners. And you'll probably find that the more often learners use this approach, the more they'll challenge themselves to notice more complex things. So you might get some people just noticing that there were 5 different choices, or maybe they'll notice that good was the most popular, or some might say unsure was the least popular. Some might start to total up the number of people, like Yvonne did earlier on in it as well. So there's loads of different scope for that. Some might start to find the difference between different options and things like that as well. And the text just on the left there shows some of the benefits of using that approach. Again, you can go back to that and look at that in more detail if you wish later on. This is just some more examples of goal-free problems, just covering different levels. We do try to kind of get everybody cover all bases. It's difficult when you've got such a wide range of practitioners as well. But once you've given learners a chance to work out whatever they can, at that point you can, if you wish, share a goal-specific question. And often what will happen is that the learners will realise that the hard work of answering the questions has actually already been done through the observations that they've already made. And maybe it's just a wee kind of final tweak that might be all that's needed now as well. Okay, we are coming towards the end of all these strategies, so please don't worry if you're starting to feel bombarded. We've got a couple more and then a couple of other things to share with you, and then we'll be done. So this approach is called same surface, different depth. Again, that wasn't one of the more popular ones that people were aware of when we did the survey earlier on. But these are problems that are a special type of problem based on the observation that the correct solution to most mathematical problems involves 2 steps. And the first step is being to identify the strategy needed to solve that problem, and the second being to successfully carry out that strategy. So the learners are provided with a number of problems which at first glance look very similar, and if I can just click and talk at the same time, which is challenging, they look very similar just to start with, but actually each of them is very different underneath the surface of it as well. Therefore, same surface, different depth. So in this case, each one starts with the same sentence: an apple costs 37 pence in the tuck shop. But then what's been asked of them each time is slightly different. So have a wee look at the ones here. I'm just going to pause for a moment, and I want you to think about the different skills that are needed for each one of them. You don't need to put it in the chat, just have a wee think about it. Okay, you probably had a wee chance to look at least 1 or 2 of them anyway. What I would say is we've got a mini guide again, which we've linked to on the thing link, that just looks at these a wee bit more detail. So if it's something that you're quite interested in, or something that you want to come back to later on, you can go in and have a look at that, and it gives you examples of what they look like and how to kind of use them, and also some further links that you can link into as well. The same surface, different depth problems can be used in different ways. You might use them as homework tasks, or you might use them as a kind of revision or for assessment approach. And the use of these problems can encourage students to think hard about the problems that they're presented with, and allows them to just benefit from the effects of revisiting concepts that you've previously covered with them, and just see if they've been able to kind of retain that learning and those skills. So there's some more examples here, and these have all been taken from a website. Too soon. A website created by Craig Barton, who you may or may not have heard of. This particular site has, I think, over 200 sets of free to download problems that he's kind of curated from teachers across the world at different levels, and it is worth having a look at these. There's quite a lot of secondary ones on there, but there are also ones that are suitable for primary as well. Okay, Venn diagrams was quite a popular one, so I'm going to kind of move through this quite quickly. But I think probably when I was in class, I wasn't actually thinking about using Venn diagrams as a problem-solving tool, and actually it's really useful for a problem-solving tool and helping learners to kind of link mathematical concepts and select and communicate their thoughts and their solutions and their processes as well. So just so that we're all on the same page, I know it's something that a lot of people said they were aware of, but just there'll be one or two out there that are maybe not. It just involves learners sorting and classifying a given set of objects into two sets or more, and often using it when they start, based on kind of the shape or colour or any other attribute. Quite often it can be good to get the learners to actually think about what they want to, how they want to sort it and how they want to do it as well. But using Venn diagrams often starts just with using hula hoops. And at early level, this might be two hula hoops that aren't yet overlapping like the ones in the picture here. And I'm not going to look at this one in particular because I'm going to actually just break it down and go on to the next slide and show you a kind of like just step-by-step guide. So I said there about the Venn diagrams often starting with separated circles or hoops. And in this case, we've got two hoops and we've got some shapes. And in a moment, there'll be some more coming. So just have a look at these shapes here. And as I reveal the objects, consider which hoop they should go in. So should they go in the red shapes hoop or should they go in the triangles hoop? So just look at those ones. You'll be able to think about that quite quickly. Okay, add in some more, just think about where it goes. Some more as well. So you'll probably have a good idea of where these are going. What about this blue sphere? Where would that go? All of the objects that I've shown you so far would go in one of these hoops, but where would the blue sphere go? Any ideas? Outside, love it, capital letters. Yep. And the reason we've put this in is because it should remain out the hoop, but actually that's another category. And I think sometimes when we're using Venn diagrams, no, I like the capital letters. I think sometimes when we're using the Venn diagrams, we often just kind of restrict ourselves to the categories within the hoops, but actually out with the hoop is a category itself. And we're just encouraging a wee bit more depth of understanding if we also look at items that can't actually go under any of the categories as well. So on the next slide, we've just kind of categorized it. So you'll see all the red shapes are in here and the triangles are here. And then we've got the blue sphere on the outside there. What about this? If we have a red triangle introduced, where would that go? Any idea? And I'm sure you do. It would go on both. Yep, and we need to overlap the hoops, absolutely right. So this time we've got the hoops overlapped. We've still got the red shapes on the left-hand side, but not on the overlapping part. We have the triangles on the right-hand side, again, not on the overlapping part. And we've got the blue sphere, because don't want to forget about the non-category as well, sitting outside. But we do have this new category where we've got, it's overlapping and it's a red shape, but it's also a triangle as well. So let's have a go. In the chat, what I want you to do is think about a number that could go in category A. So this is this section here. So this would mean it would have to be an odd number, but it can't be a multiple of 3, as that would go in a different category. So what is an odd number that is not a multiple of 3? So we've got some answers coming in here already, which is good. Okay, good. So I've got a few in there. That's not to say if yours isn't there, it's not right. We just put a few in there for an example, so good. Okay, think about category B. So this time, that's this area here, it has to be a multiple of 3, but not an odd number. So what could go in there? 6, 18, good. Great. And normally I'd give you a lot more thinking time, but we just don't have the time for that. So some examples there. There's also some correct ones in the chat there as well. So quickly, let's look at C. So this time it has to be an odd number and a multiple of 3. Where should that, what could go in there? Yep. And there's other, again, it's not just those ones as well. So D, because we can't forget about the non-category. What could go here? So it can't be an odd number and it can't be a multiple of 3. Any ideas? And you can see how this is quite open-ended as well. Okay, here we go. So I am aware that we've talked a lot today about lots of different strategies, lots of theory and things as well. I do suggest that you go back and you take time to look at the presentation again, pick something that you think you would like to try with your learners, keep going with it until you think either you like it or you don't, but don't just try it once. You can go onto our professional learning community, which there's a link to on the screen here, which has got lots more things to do with developing mathematical thinking, lots of links to external websites and various different things that you might find useful. This here is just the professional learning community. Just want to kind of remind you that it's there. You do need a Glow login to access it, but there's loads and loads of material and professional learning. And you could probably use some of your CLPLers if you haven't already used them up, which you probably have. But you can put that down because it is professional learning it's included in this as well. Quick reminder of the programme. We changed the date today. Obviously, the next live session is the 16th of May. We haven't set a theme for that yet because we want to take your ideas. We've got a quick wee survey that we want to just kind of scope your ideas to see what you would be interested in, because we want to make it what's useful for you, not what we think is useful for you. Also, there's this is just a reminder of the thing link. We have been kind of look and see, it has been getting regular hits, but it's just to remind you that it's there. You don't need to work through all of the modules. You can work through the ones that you want to do. We'll hopefully be able to make this available next year as well so that you can go back in and have a look at it. But the last 3 modules at the bottom will be released on the 1st of February as well. So by that point, they'll all be out as well. And if you've not had time to look at that, don't worry about it. It is there. If you've got some time, you can go in. You only need 5-10 minutes at times to go in because you can the videos within it are all quite short as well. Maria mentioned earlier about the drop-in, so please do come along. I know that we've had some questions in the chat, in the Padlet tonight that I've not actually had time to look at properly, but these are things that we can talk about there as well, and it might be that we take some of the themes from the ideas that you're suggesting and use them within some of the drop-in sessions as well. Also, just a quick reminder that we do have a Twitter page at EdScott Math, so please do have a wee look at that. Give us a follow if you're on Twitter, because we post, any other training, things like that as well. So this here, what we want to do is, some of you have actually gone on already and done that, so thank you very much. It's the same Menti that you were in earlier on, and really we just want to kind of scope what are you finding useful about this programme so far, because this helps us shape the final session. It also helps us shape it for people next year as well. What impact is it having, if any? It might not have had any impact yet, and that's fine. Maybe it's had a small amount of impact. Maybe it's had a huge amount of impact, which is great. But please just put in that. And also there's 3 more slides in that Menti that you were in earlier on, and we just kind of want you to go in and make suggestions. If you don't know yet, because you think, well, I've already had a lot of thinking tonight, I can't think anymore, you're welcome to email me, because I always email all the joining instructions or the mathematics box if you've got any suggestions that you would like used. I'll also leave the Menti open for a week or 2 so you can go back in, and once you've had time to kind of process it, have a wee look and see what you think. So just to be clear, the PowerPoint slides will be emailed out. I'll email them out probably tomorrow morning, and the recording of the session will also be added to the thing link when our lovely Ian Fife gets it edited for us, and he's always very quick, which is great, and we're very grateful for that, and that'll all be added to the thing link again as well. So yeah, what we'll do is we'll hang on well, we're actually finished early, which is great. We'll hang on for a wee bit, and if anybody wants to just talk about anything or go through any questions that you've got, what I'll do is I'll turn it on so that you can put your cameras and your mics on, so if anybody does want to ask a question, you can either put your hand up or unmute your mic as well. So, and thank you for coming, because we do appreciate this was a lot at the end of a day, but hopefully some things have kind of resonated and you've been able to take something away from it. So thank you.